Hey everybody, so in this video I'm going to be reviewing the material from chapter 21, Living in the Environment. This is part of our 8th unit in environmental science where we're going to look at solid and hazardous waste. So what is waste? So solid waste is any unwanted or discarded material reproduce that is not liquid or gas. So we've talked about air pollution, we've talked about water pollution, and now it's time to talk about the physical matter that we don't need anymore or don't want anymore. And we'll focus a lot on municipal solid waste, which is produced directly by homes and businesses, but that only makes up about 2% of the world's solid waste. And this is stuff that you're familiar with because you have to throw it away. Paper, food waste, cans and bottles, plastics, elastics, textiles, etc. All of these materials are stuff that once you're done with them, you have to figure out where they go. And the majority of this stuff is going to end up, at least in the United States, buried in a landfill or incinerated. In other locations, and certainly part of what we do here in the United States, is to not track it, and it can end up somewhere else in our oceans and waterways especially. Or if we're really good, we can compost or recycle materials for use in the future. Industrial solid waste makes up the vast majority of waste that humans produce in this planet, and that is produced by industries. That material can come from mines, it can come from farms, it can come from industry. A lot of that is buried or incinerated as well. And most of the industrial work that produced wastes are mining and oil gas production and agriculture. And all that material needs to go somewhere. So we have to figure out what to do with material once we are done using it. The United States, which makes up only about 4.5% of the global population, generates 35% of the solid wastes. We are the most wasteful country in the world, without a doubt, per capita. And most of that, like we said, is industrial, and the rest of it is up to us. That's municipal waste. 13% is going to be burned, so we have energy in using incinerators that are going to burn some of our solid waste here in the United States. We're getting better at recycling. These numbers are a little old, so the first day of this unit we'll look at some numbers in a little bit more, but roughly about 35% is recycled or composted. And then the rest is going to be buried in sanitary landfills. We no longer typically use unsanitary dumps, although you will see parts of the United States where these dumps are still used. Not necessarily legally, but because people collect that material and sort of leave it. Landfills are problematic in that as materials start to break down, some materials break down faster than others. Water is going to infiltrate into these essentially piles of trash, and as that water goes in there, it's going to interact with the breakdown of the waste, and it's going to create what we call leachate. So 86% of older landfills in the United States are going to contaminate the groundwater near them. Also, the breakdown of the material in that landfill is going to create greenhouse gases like CO2, but also methane, which is produced when there's anoxic conditions in the sort of center of those piles. And 20% of our superfund, which we'll talk about later, but our superfund sites are hazardous waste sites, and they are former landfills. So we're seeing that there are hazardous wastes, especially in the older landfills, that are leaching into nearby waterways, creating dangerous gases, etc. Over the last few years, the biggest growing area of waste is electronic waste. This is discarded televisions, cell phones, computers, headsets. All sorts of things are going to end up in the landfill unless we specifically move it to another location. And so a lot of municipal waste facilities now collect e-waste. We produce about half the world's e-waste. And we're not very good at recycling it. It contains both a mixture of plastics, metals, toxins, We can find PVCs, we can find lead, we can find mercury, we can find cadmium, we can find copper and gold and silver, all sorts of heavy metals and plastics and other materials that aren't very healthy are going to come from e-waste. And so we need to dispose of it in slightly different ways than we do other waste. So once you've produced the waste, you have to figure out where it goes. Waste management is how we figure out where that material goes. And we want to make sure it ends up in a place where it's going to do the least amount of environmental harm. To ensure proper waste management, we need to prioritize waste reduction before we even get to the stage where we're actually generating the waste. So we need to just produce less. Or if we are producing waste, we need to reduce the amount that's going to end up in our incinerators and our landfills by making sure some of those materials can be recycled, can be reused, can be repurposed, can be composted, etc. And so we're moving towards, and most municipalities are moving towards what we call integrated waste management, which uses a variety of strategies for disposal, a variety of strategies for encouraging reduction, a variety of strategies for trying to find other fates for that waste before it ends up in a landfill or needs to go to an incinerator. And so, like I said, our first priority should always be the prevention or reduction of that generation of waste. We need to change industrial processes to eliminate harmful chemicals in our materials so that it doesn't end up in our waste. We need to purchase different products, ones that are reusable, ones that don't have as much packaging, and we need to just make sure that the life cycle of our products are really long, or are cyclical in nature, that we're not going from cradle to grave all the time, but we could actually go cradle to cradle and make the life cycle of a particular piece of material sustainable. Once we've generated some waste, we want to know, okay, what parts of that waste can we reuse, can we repair, can we recycle, can we compost? And so the second priority in integrated waste management is this idea of finding a different fate for our waste other than just putting it into our landfills or putting it into our incinerators. And our very last priority should be that, where we have to treat waste to reduce toxicity, where we're going to incinerate some of it, we're going to bury the rest of it, and hope that it stays, right? And hope that it doesn't end in other parts of the environment, like our waterways and our oceans, to cause problems where it breaks down into microplastics or other materials that, quite frankly, there may be no natural existing enzymes that break it down into reusable inorganic material for the future. So, the 5 R's that they refer to are refuse. So let's stop buying items we don't need or items that we don't, items that are unnecessary, essentially. Reduce, so consume less and live a simpler and less stressful life by practicing simplicity. This is going to be, let's just reduce the amount of material by changing our lifestyle. Reuse, rely on more items that could be used over and over, so make sure there's a fate or a future for that item to go to. Often this will be, clothing that gets passed on, clothing that gets donated, materials that can be sent from one child to the next as opposed to throwing something away, etc. Repurposing is taking something and using it for a different purpose instead of throwing it away. This could be taking the wood from a desk, breaking it down, using that wood to make a toy. Something that involves making sure that material doesn't end up in the landfill, and then recycling, right? If we have an item that is made out of something that's useful to us in the future, we can take that item and properly recycle it. So this is glass, right? This is basic silica glass. This can be melted down into raw material and reused again to make another glass item. So in the case of recycling, while it's still energy intensive, it's going to, in terms of the life cycle of that material, be more energy reasonable in that it's not just one use and you throw it away, but you actually recycle it and make sure that that glass ends up not in a landfill but somewhere else. it's a really good image, and I want you to sort of spend some time actually tracking these arrows and thinking about what are the fates of the materials that we generate, and where can the fate of that material be cyclical, and where is it only a one-way path. So we'll talk about the differences and sort of pros and cons of either burying our wastes, which we primarily do here in the Bay Area, or incinerating waste. And there's only about 13% of our wastes in the United States are actually incinerated. There's different laws in different states and different countries about incineration. Some places use it primarily. Some places make it illegal because of the waste that it, air pollution waste that it produces. But if we are to burn our wastes, in some cases, heat can be generated during the burning of that waste, used to boil water. That's going to make steam and produce electricity, which can be sold back to the market. So there are some pros in that we get energy generating benefits from burning our garbage. The burning of that material is going to reduce trash volume, and it also will concentrate hazardous waste that may not break down through the burning process to be treated and disposed of in a more careful manner. Incinerators, however, are expensive. They do produce these hazardous wastes. When we burn materials, it releases CO2 and other air pollutants. And in some countries, they're finding that the fact that you incinerate generates or encourages waste production so that you can keep up your generation of electricity from that plant. Whether or not that's a valid con, I don't really know, but I think it's an important one to consider. Burying waste, here's a capped landfill. This is an interesting capped landfill because it actually has solar panels on it, so they are reusing that space properly. There's lower operating costs. All you really need is a bunch of trucks to dump and mat down the material. And it allows you to concentrate a large amount of waste in one place, so it's out of the way of site, essentially. That filled land, as I said, can be used for other purposes. In this case, we are seeing solar panels put onto that land. I've seen landfills used for parks or areas where you can do athletic activities. You would never want to build housing on or even business on those areas, but certainly there can be other purposes from a landfill. And we have the space in a lot of places, especially here in the United States, to make these landfills. However, if you live close to one, you're going to experience the noise, the traffic, the dust, and particularly the smell, the methane smells that come from the breakdown of these materials. Methane is probably, the gas that you're most concerned about being released from a landfill, but CO2 will also be generated. If it's collected, that methane can be burned and used for electricity generation, which is really nice. Again, another con, some people say that having a landfill around encourages people to continue to generate waste. But the biggest downside, and certainly the biggest concern when you're establishing a landfill, is that it contaminates groundwater because the leachate will leak out of a landfill and cause issues. Here's what an incinerator looks like. It's actually not all that different from a coal burning power plant where you have a pit of the collected waste. That material goes into a large furnace where we actually burn that material. Water is added so that the ash is not going to create a lot of air pollutants, but rather is collected as bottom ash, which is then sent to a landfill. The gases that are generated during the burning are going to be sent through a boiler. This is going to basically take the heat, create steam, spin a turbine, and generate electricity. And that gas is going to be sent through a wet scrubber, which uses, again, water to pull any of the aerosol fine materials out of that gas. Again, that's going to get sent to waste treatment facilities. And then usually they'll run them rest of it through an electrostatic precipitator to get out anything else in the fly ash, which is generally the most hazardous part of the waste that's produced, and that gets sent to a specific landfill area where it can be treated. And then we actually get rid of the rest of the air that's polluted. So not all that dissimilar from coal-burning power plants. Landfills are a little bit more complicated. In order to be a legal sanitary landfill, you need to do a number of things. Essentially, you need to make sure that the landfill is capped when you're done, or layered with things like clay and sand so that the garbage won't fly away. The bottom of the landfill, the underground part, needs to be sealed so that you don't have leachate just entering the groundwater very easily, but rather have a collection system of piping that collects that leachate and will send it to some sort of treatment facility, whether it's on the grounds of that particular landfill or a nearby wastewater treatment facility. Essentially, we want to make sure we're collecting any of the water that leaches out of the landfill and treat it before it ends up in our groundwater. To legally do this, you need to have a number of monitoring wells that allow you to actually test the groundwater nearby and test the surface waters nearby to make sure that that landfill isn't leaking. The other thing that you're going to need is a number of methane pipes that are running through the landfill itself. This is going to allow the gas to come out of the landfill. And usually what we'll do is either let that gas be released into the atmosphere, which is not all that useful, or we'll actually collect the gas and send it to some sort of storage or some sort of electricity generating plant in order to actually make use of that particular material. We'll talk about this in more detail, and we'll actually do some calculations looking at area of these landfills, volume of these landfills, the amount of water and leachate that is produced, etc., to understand their impacts a little bit better. The last thing I want to talk about is hazardous materials. These are wastes that are also considered toxins. So they've been classified as toxin because they have some sort of threat to human health. Typically, this will be chemical material that is toxic, but we also want to look out for hazardous wastes that are ignitable, corrosive because they're acidic or highly alkaline, flammable, or some sort of reactive, chemically speaking, that can release toxic gases that somebody might breathe in, or could potentially, blow up or combust or cause some sort of issue related to that. The EPA estimates 80 to 90% is produced by developed countries. I don't know if that's necessarily true, but it's likely that those places have fewer policies around the use of hazardous materials in products, and is produced by chemical or petrochemical industries. A lot is going to come from mining and metal industries, which is not surprising. In the United States, the Resource Conservation Recovery Act in 1976 only regulated about 5% of the hazardous waste following the cradle-to-grave system. And once that material went into a grave, wherever it was no longer being tracked or couldn't be tracked long-term. And so, Superfund sites are sites that are previously used for the disposal of hazardous waste material now are tracked through the Comprehensive Environmental Response, Compensation and Liability Act, which was engaged in 1980. We call this CERCLA. It's also known as the Superfund Act, where companies that are responsible for hazardous waste disposal, even if they didn't dispose of it properly, or even if they did and it leaked out somehow, can be held accountable for side effects from that material many years later. This act will sort of cover some of those costs to make sure that people aren't having to pay out of pocket for those particular sites if they need to be cleaned up. And some issues around the CERCLA Act is that these companies have gone out of business, and it's really hard to track down who is actually responsible for these sites, who's actually going to clean up these sites. Only 70% of the cleanup costs have come from the polluters, and the rest is basically financed by the United States government in order to keep cleaning up this material. Other wastes that we have to think about include radioactive, which we've talked about when we talked about nuclear power generation and how we mostly bury the radioactive fuel rod waste. Household chemicals are often thrown out or sort of go through no regulation, despite the fact that municipalities will have policies for how to deal with those chemicals. Most people will just throw them into the municipal trash. Basically, anything generated in a quantity of less than 220 pounds per month is not really regulated by laws here in the United States. And so that can be, pretty serious. The two largest classes of how we classify hazardous waste include organic compounds, PCBs, dioxins, any of these persistent organic pollutants, and then certainly the heavy metals, the lead, the mercury, the arsenic, etc. And the EPA really wants to track those things and try and track down, who wasted them in the first place, or who generated that waste, and how do we hold those people responsible. So if you have a hazardous waste, how do you manage it? Well, we're going to have special landfills that are designated to deal with hazardous materials. Physical methods including using charcoals, resins, etc. to separate out harmful chemicals or render them inert. Chemical methods, we're finding some sort of chemical reactant that can convert whatever that hazardous material is into some less harmful material. Or specialized incinerators. Hazardous waste systems don't operate in the same way as sort of a municipal waste incinerator. You have to superheat the material, send it to really high temperatures to break it down. And so one of the methods to do this now is the plasma torch, or basically passing electrical current through a gas to generate an electrical arc to create a plasma through that material, which is going to have a very high temperature and can break down liquid or solid hazardous materials. When we cool that gas down, it's often, still has a bunch of hydrocarbons in it, and so we can use it as synthetic gas. And in some places, we are still doing that. We are doing that now, which is great. And then the sort of other policy is storage, right? We talked about this in the case of wastewater from fracking. We talked about this in the case of fuel rods spent from nuclear plants. There are some hazardous wastes that we don't burn or we can't treat, and so what we do is we package it and we bury it. We have deep well disposal systems where we pump it into rock that is hopefully not an aquifer. We have surface impoundments where we'll actually create some sort of surface holding pond where we can store liquid wastes. That pond has to be lined, has to be monitored for basically the rest of the life of that material for a long time. Long-term retrievable storage is where we put materials often in bins or drums and bury them and make them, impervious or inaccessible, but we could go down and retrieve them if we wanted to. And then secure landfills where hazardous wastes are put and buried and monitored for the rest of their life until we have the better technology to be able to break that material down or something of that sort. we have 23 commercial hazardous waste landfills here in the United States, and certainly not all hazardous wastes end up there. There are some environmental ways that, more sustainable environmental ways that we can break down hazardous materials. Bioremediation involves the breeding of bacteria or algae or certain enzymes to help destroy toxic or hazardous wastes. So we're working on that. Phytoremediation involves using genetic plants to absorb or take up or use materials, contaminants, to essentially remove them from the environment and then put them into something that is more collectible or usable. So we're starting to see more technology allow us to do better and more sustainable solutions for dealing with these hazardous wastes. And I think this image shows a lot of really cool possibilities for both radioactive contaminants, or inorganic metals, and how we can take them up out of the groundwater, how we can take them up out of the soil, how we can take them up from surface waters, etc. So generally speaking, if you're answering an AP question related to this unit, less waste is going to always be your go-to, and then converting that hazardous material into a non-hazardous or less hazardous material using a variety of treatments. And then last possible fate should be perpetual storage or long-term storage for these materials. What happens to these over time, who's going to monitor them, 50, 100, 300 years in the future is sort of the biggest question right now. Will we lose the paperwork that says, hey, here's where a pile of hazardous waste is buried? That's likely to happen, and somebody will find it again in the future, but it's a little disturbing to know that materials can be out there and not be being tracked over the hundreds of years of that life cycle of the material.